Hello, everyone. This is Francesca Vigliani from Cloud Academy. Welcome to the final episode of our Mastering Machine Learning webinar series. I can't believe it's already the fifth and last episode. It has really gone by so fast. I'm seeing lots of people joining in, several returning attendees. Good to have you back. But if it's your first time joining us, you can catch up by watching this series on demand on our dedicated page, which is cloudacademy.com/webinars. You will find all the previous ones on the Mastering Machine Learning webinar series. On top of that, you will also receive the links to the recordings in the follow-up email for today's session. Before we get started, just a couple of housekeeping announcements, and then we can get going. As usual, this webinar is being recorded and will be shared with you via email. At the end, we will hold a Q&A session, so feel free to submit your questions through the chat box. All right, I'm all done with the announcements, so without further ado, let me introduce you to our data scientist, Andrea Giussani.
Thank you, Francesca, and welcome everybody. So nice to see so many people even today, and thank you for participating as usual. For me, it's a pleasure to speak to you throughout these webinar series. So today's topic is natural language processing using Amazon SageMaker. So we're going to mix a couple of fields, which is machine learning from one side, basically on natural language processing, and then we're going to speak about about clouds technology. In particular, we are going to use a Amazon SageMaker service, which is a very popular cloud service that is used to train and deploy machine learning models using the AWS infrastructure. So just a few words of myself. I'm a data scientist here at Cloud Academy, where I mainly focus on the development of machine learning algorithms to provide state-of-the-art solutions in order to provide to improve the quality of our products. You can reach me out on LinkedIn if you want to be updated on Python or in general with machine learning stuff. I'm free and fully available to answer to your question. So don't hesitate to write to me. It's a pleasure for me to help you. And as Francesca said, the webinar is recorded, and you will be able to watch it back. And the link is provided in the GitHub repo. And you can also get the full transcript of this webinar session in that particular GitHub repo.
I just shared it again in the chat, so have a look, and the link is there.
Thank you. And it's important, let me say like this, that this is not going to be a standard webinar in the sense that we're not going to use any Google Colab environment directly as we did in the previous sessions, but we're going to use SageMaker. And in particular, I want to show you how to basically set up a Jupyter notebook inside a SageMaker environment. And in particular, I need a few snippets that I provided in the last episode. So what you can do is actually going into the GitHub repo. You should be able to see here in my screen. You go into the episode 4 and you go into the episode 4 student file. And here you find those three snippets that we're going to use later. Don't worry for the moment. Just be sure that if you want to get your hands dirty during this session, be sure that you have those paragraphs that you see here close to your browser. Okay, so let me go back to slides. So as usual, we are going to understand the webinar topic and the learning objective. And today, obviously, the environment is dedicated to SageMaker, and we are going to understand how SageMaker is built and how it works. Okay, so this webinar has been thought for data scientists, data engineers, and in particular data analysts that wants to learn more about AWS SageMaker. In particular, we are going to learn how AWS SageMaker works in a pretty general overview. We are going basically to open a Jupyter Notebook inside the AWS SageMaker service. And in particular, as the title suggests, we are going to perform a few NLP tasks that will allow us to explore the Hugging Face Transformer library that we got to know in the last episode, thanks to the sentiment analysis pipeline we built in the last webinar. And last but not least, obviously, this is the 5th episode of our 5-episode webinar series entitled Mastering Machine Learning. I hope you have enjoyed as much as I did. And unfortunately, it's the last episode, so feel free to suggest anything that you have in mind for future webinars. Francesca and I will take seriously your consideration and see whether we have room for your request. And as usual, in case you want some chat with me direct, just drop me a line via LinkedIn. It's easier for me. As usual, in order to successfully attend this webinar, you need at least an intermediate level of Python. That's pretty important. And also a little bit of knowledge on how AWS works in general, which means how data are stored in AWS, and so therefore a little knowledge of S3, and in particular on AWS SageMaker, how it works in general. Obviously, this webinar is 100% free and open source. If you register in AWS with a subscription, with a free trial subscription, if you have never registered with your email to AWS service, you have the possibility to learn how AWS works for free. But I want to also show you how hands-on lab in Cloud Academy works. And so I will try to show you how SageMaker works via an hands-on lab, which is available in our content library, so that we don't have to care about how to set up the right infrastructure and the right permissions in order you to be able to run a Jupyter Notebook inside SageMaker. Okay, so after this webinar, you will be able to understand how the Transformer library works to perform natural language processing tasks such as summarization, question answering, and translation. That's pretty important. Understand how SageMaker works and which service you can use in general to perform machine learning. And last but not least, you will be able to enjoy the Cloud Academy hands-on labs. And this is pretty important because in Cloud Academy we have tons of also possible thanks to the hands-on labs. Okay, so as I said, my idea is to go through the SageMaker environment at first. So without further delay, let's jump into the documentation at first. The documentation is well written, so I strongly suggest you to go through it because it's pretty clear And you can understand not just how SageMaker works, but also you can go into the details of a few services like Autopilot or Augmented AI, which are particular services inside SageMaker that we are not going to see together. But it's important that you know that SageMaker is not just training and deploy machine learning models, as we typically think of, but there are many other features that allows you to preprocess your dataset or to build and create a machine learning pipeline, an automated machine learning pipeline, without need of machine learning knowledge or experience. That's pretty cool. And there are also a few interesting services like the Data Wrangler. This was introduced in the reInvent 2020, so last year. It's a pretty interesting service since it allows you to actually perform all the pre-processing steps that we have seen in basically episode 1 and 2 in this webinar series. If you remember, we were dealing with imputation, we were dealing with categorical variables, and creating or performing better featuring engineering requires a lot of knowledge on one side, but also some efforts. So in order to perform this data wrangling and data manipulation, you can use a service inside SageMaker. Okay, it's full. It's a very nice service, and even in the last reInvent, many other features went out. So SageMaker is pretty an interesting service where AWS is investing on, and in particular, people are spending time and spending money in using it. So it's important that you get to know this service. How do we get to know? Well, as I said, we are going to explore a SageMaker Lab inside the Cloud Academy environment. And in particular, what I want to use with you is, I hope you know, let me say like this, this is the website of Cloud Academy. So I hope you have enrolled if you came here. Otherwise, you can try it out and by yourself. But I suppose that you got to know Cloud Academy. So let's try to look for a SageMaker Lab in our search. And here you can find this hands-on lab called Using SageMaker Notebooks to Train and Deploy Machine Learning Models, made by Logan Rickey, which is a content creator here at Cloud Academy. And in particular, this is a typical lab page where you find a description of what you're gonna perform during the lab, and the objectives, basically the skills that are gonna be tested during the lab, and in particular the prerequisites. Sometimes the prerequisites are suggestion, but that doesn't mean that they are not important. Here it means that you have to know a basic programming knowledge using Python, some knowledge of machine learning concept is beneficial but not required, some S3 concept, and the completion of a forecast flight delights with Amazon SageMaker is recommended for a deeper understanding of the data. Let me say like this, that for us, it's not pretty important, that stuff. It's important that you get to understand how SageMaker works if you want to perform an end-to-end train and deploy. So at the end of the lab, you will be able to train models using a SageMaker. And in particular, we have this class called SageMaker Models, which is nothing more than a wrapper that allows you to create a model and use that model to perform a real-time inference. So we will try to see how that works. And in particular, everything, all the code is being written in Python. And in particular, we're going to use pandas as a Python data analysis library. Okay, so once we've done that, we can start the lab. And once you start the lab, you have here 1 hour time to complete it. And you see here, you have 3 lab steps. The first one is logging into the AWS Service Console. Another one is opening Jupyter Lab on your Sagemaker notebook. And finally, working through the Jupyter Lab notebook. Okay, so we can actually go into the first lab, which says that we have to basically follow the instructions that are provided here. And the instructions are pretty simple. It says that we have to open an environment and sign up with those credentials in order to access to SageMaker. It's pretty direct. It's not complicated here. We are also suggesting to use either Google Chrome or Mozilla, but that's not really compulsory. Okay, so let's see, the environment is setting up. Let's wait a few seconds. Meanwhile, I'm going to show you again the documentation. And SageMaker, in particular, was born for data scientists to train and deploy machine learning models. And as you know, typically the development phase of a machine learning project happens on a Jupyter notebook. So here you will see that there is a nice section called Get Started with Notebook Instances. And we will try to understand how those instances work today. You have a very detailed guide that allows you to create an Amazon SageMaker notebook instance and then train and deploy a model following that documentation. So it's pretty direct, okay? We are going to, it's not necessary that now you go through that documentation because we are going to focus in our webinar on those 7 steps. Let me see whether the environment it's not being set up. Let's wait. So no, there is pretty slow. Okay. Let's try again. Since we are having some issues. Since we are having issues, sorry for that. Okay, seems we are not able to get into the environment. So let me go in this way. So just to give you an idea, this is the environment of SageMaker. So unfortunately, I'm not able to open Cloud Academy Lab. Sorry for that. So let me go directly into the SageMaker, and we are going to perform our analysis without the lab. Sorry, there is an issue, so I wasn't able to log into it. So this is the SageMaker framework, and you see, as I was saying, that typically data scientists go either through a notebook instance or with a training job instance, either with a simple training job or even with an hyperparameter tuning job. We're going into that in a few seconds. So just to clarify, a notebook instance is nothing more than a Jupyter notebook. And the nice thing about SageMaker is that it allows you to choose between among different machine. If you think about a Google Colab environment, gives you the possibility to use GPUs, but with a limited time. And in particular, even a machine without GPUs cannot be customized. Whereas with SageMaker, you can actually check it. And there is a list of available machines that you can use when creating an instance, as we're going to do in a few seconds. And well, you can choose a general purposes machine, which are the cheapest one. And then you can either use the accelerated computing, which are machine that has a possibility to use the GPUs. Okay, so those are obviously more expensive, but as you can see, you have different machine that you can actually pick from and start training your model, especially if you are using a very complicated model like deep learning models for machine learning stuff. So as I said, we can actually create a notebook instance. And in order to create a notebook instance, we can go here and let me call this test. And you can choose the machine you are interested in. I'm gonna pick machine learning T3 large. Just it's pretty standard machine. And in case you are curious for the specification, we can actually Google it. And here you have the pricing, for instance. So for a notebook, in our case, in a region which is US West, for instance, you can actually see that AML T3 large has 2 CPUs with 8 gigabytes of memory, and it costs 10 cents per hour. And it's a standard machine, okay? And as I was saying, you can find those accelerated computing, which cost much more, obviously. But think about here, you have a machine with P3 8X large has 32 CPUs with 244 gigabytes. It costs, but it is a very nice machine, especially if you want to perform accelerated computing. And the GPUs is available when you typically use a training machine. And indeed, if you go here, the accelerated computing has obviously the same here. It should also show the CPUs, but it's not. So anyway, these should have at least one GPUs, but there must be some other examples where they show you how to choose the right machine for your purposes. So let me go through here. Here I'm not gonna add anything. I can create a notebook instance. So test 02, for instance. So once we have created, we have here basically the standard home page of our machine. So we have the details that we have about our machine, the GitHub repo in case we have some repo link to our project. I obviously skip it because it's not important for the moment, but you can check by yourself. You can add your GitHub repo in case. And then here you have the permission via the IAM role. And here you have some logs, because automatically when you create a machine, also a CloudWatch logs are provided in case you want to debug your code. So here we have to wait because it's setting up the machine. So once the machine is ready, we can actually start our Jupyter Notebook. So just a few seconds. Let me check whether the lab went fine. Yes, so the lab went fine. So in case we can directly join the setup here. So what we can do is actually opening the environment. And my suggestion is open an incognito page so that once you end up here, you can actually fill your information with the account ID that Cloud Academy is providing for you, the student name, and the password is the one provided here. I join it. Okay, so this is the typical AWS management console. We go into the SageMaker. We have already seen it since we were working with different environment before. So please go here in the notebook. You go into the notebook instances, and here you find the CL Lab notebook. And you can obviously open the Jupyter. So a Jupyter instance is opening for you. Here we go. So we got a folder called SageMaker Flight Delays. And we open the lab.ipynb file. And here you find all the steps that as a learner you can go through in order to successfully complete the lab. So let's go just through a little bit together in order to understand how this lab works, and then we are going to see some application on natural language processing. So here it's basically saying that we have to prepare the data. So we are going to get the data from S3 bucket, and we import the data and we read that data. Okay. And then we are going to perform a simple data preprocessing. In particular, we are going to check the type of our columns. And in particular, we also read the data that we imported in the first two cells with the particular D types that we just specified in this cell. We can also print the distribution of the target arrival delay. Here we go. So you can see that we have a distribution that is pretty centered in 0. So it looks normal, Gaussian, let me say, but it's a little bit skewed. So it's not pure Gaussian. But as the description is saying, the majority of flights arrive in less than between 0 and minus 25. In particular, it says in minus 6 minutes. That is the peak here. So it's important that we have understood how the data works at least at the beginning. So here is performing some pre-processing, is converting the categorical variables into the dummies. Okay, using the get dummies function. What does it mean? It means that, as you know, a categorical variable cannot be ingested in the algorithm. So we are going to convert that categorical as a dummy variable, which means 0, 1 for each single possible value observed. We have a big data set, 1,100,000 rows. Here we then get the available S3 buckets. It's a standard, it's pretty standard way to get the buckets. At the moment, the machine has just one bucket from which we are reading the data. And then once we get that, we are basically gonna create here the train and the test set. Then we are going to upload those data using a simple protocol. And in particular, we're going to upload the data using the function bucket object, the call object, and the function upload file before training the model. So here it says that it takes 5-10 minutes to complete. So let's try to run it. And meanwhile, we create another notebook where we get our hands dirty with natural language processing stuff. So let me go here. And I create here a new instance. And as you can see, you have many images from which you can start from. I'm going to start with a Conda PyTorch P36, which stands for an image of PyTorch for Python 3.6. You see that you have other nice images from which you can start from. The TensorFlow, for instance, the Spark Magic for PySpark. But in general, you can even start with a standard Python image, as you see here, Python 2 or Python 3. So for the moment, let me pick a PyTorch P36. So let's wait a few seconds, setting up the image. Here we go. So as I said, we are going to basically use the Hugging Face Transformer library. So let me install the transformers, in particular by also requiring the optional installation of SentMPs. Why is it not working? Here we go. So we installed the transformer library because, as I said, I would like to basically bridge the previous episode with this one inside, say, SageMaker. Okay, so remember, last time we were actually performing standard sentiment analysis pipeline. So just to recall you, we were basically doing using the pipeline object for MERS, and we import the pipeline. And in particular, we were actually using a pipeline object for sentiment analysis, right? Or even you can write also for test classification. Is actually the same thing if you think about. And then you can say, well, CLF, you can call the CLF, and you can pass actually a sentence that you want to predict the sentiment on. The book, and I really enjoy the last chapter, and something like this. Last time we performed actually a simple task, which was sentiment analysis. And if you remember, we were actually calling the pipeline object, initializing the pipeline object, and then calling the pipeline by passing the string we want to classify as positive or negative. So here he is downloading the model, possibly. So let's wait a few seconds. Here we go. So this is what we did last time, right? Performing sentiment analysis using the transformer library, and that is pretty much everything we have seen, right? But that's not the end of the story, because the nice thing is that this classifier, for instance, can be passed a list of strings, which means that it's gonna perform a classification on those two strings separately. Let me say like this, is pretty stupid. So you see here, you have that you are passing two sentences, and is returning two different scores for those two sentences, which is nice. But you can go much further, because natural language processing is not just about getting some text and in particular getting a prediction based on a sequence classification task. It's much more. For instance, typically the sentiment analysis pipeline in the backend requires a label dataset. What does it mean? It means that you have some examples. Those examples come with a label that says that a text is classified as positive or negative. And thanks to these labels, the model learns some patterns inside the data. And therefore, when it gets, for instance, that let me say the triple I really enjoyed, you understand that this is a signal of the fact that this sentence is going to be a positive sentiment. So it learns some patterns, but sometimes you can actually perform what we call the zero-shot classification. In the zero-shot classification, we don't have any training data, any label data, but you have a possible set of candidates for labels. You pass a text, and that text has been assigned with a certain probability to each single class, and therefore the one with the highest probability is then taken as the true category predicted category for that particular sample. But let me say like this in practice. So I'm going to create a new CLF, and I call this zero shot, because I'm going to use the pipeline of zero shot classification. Okay. And this pipeline requires you to specify basically the text. So for instance, this course is about the transformer library. And then you have to pass, since we don't have labels, the candidate labels, which means that this text is about, let me say, politics. This text is about education. And this text is about business. So basically the algorithm, the zero-shot classification pipeline is based on a BART model. Just to give you some context, a BART is an encoder-decoder model. That's why it is inside the transformer library. And in particular, we have the encoding part is nothing more than the BERT model that you got to know even in the previous episode. And then we have a decoder which actually generates text, and therefore is going to understand, this process is important in order to classify this text in one of the most suitable labels. So let's try to run it. So if you look at this, is downloading the BART large MLI. MLI stands for natural language implication. Is downloading the model. Is pretty heavy, 1.5, 55 gigabytes. Let's go back meanwhile here. So it finished. Okay, so let me finish here the zero shot, and then I go back to that example. Here we go. So this is the output of a typical zero-shot classification pipeline. So you get the text, you get the labels that you know in advance, and then you get actually the scores for each single category that you provided there. So for instance, it says that the most likely label that we have to associate to this text is about education. Makes sense. Business, second one, and politics, the last one, with very low probability. So somehow is getting, is learning right. So it's guessing right, because education is the most likely label to be used. But if you think about it, it might also be about business, because if we are working in educational set in an educational company, possibly a course can be identified as business. So it makes sense. I agree with his classification. And so, as I said, let me go back here to the lab. And once you have created the data, basically by splitting the data, the original data, into train and test set, we store the data, and then we can train the model. If you remember, I said that typically in SageMaker, we can use some classes called SageMaker models that contain some models, very common models, and then we can start using those models, called also estimators, to perform our training. So how does it work? Well, I'm gonna basically create an estimator based on what? Based on some criteria. This is the instance type, so we are going to use an ML-M4X large. This is the output path where the model then is going to be stored. The session, which is created by using the Sagemaker.session class here, and the role, obviously, and the container from which we start from. So once we initialize this, and obviously, by the way, we are using this library called Sagemaker, which is a very nice library available for free. So you can check the GitHub repo of that library. Is maintained by AWS, obviously, and it's pretty cool client in order to interact via Python with Sagemaker. Here I said the hyperparameter of the linear model, since we are going to use a linear model, as you see here. And then we can start training a model. This is going to take a few minutes. So let's wait, and we go back there to the NLP stuff. Okay, so this is the nice thing about Hugging Face Transformer library. In just one library, you have a lot of pre-trained model, transformer model, from which you can start from, and you can actually perform natural language processing without the need to train a real model in your local machine or even in Sagemaker. So think about generating text. It's a pretty complex task, but again, with Transformer, you can do that in a pretty easy way thanks to Hugging Face. And we can actually create a generator pipeline, which is obviously the instantiation of the pipeline object with the text generation. And the generator, you can pass an incipit, basically as a beginning sentence, like in this course, we will teach you how to do some stuff, okay? So I'm curious to see, given this starting sentence, how a transformer model is gonna complete the text, okay? So text generation, sorry, typo from my side. So it's gonna use GPT-2. Possibly you got to know what GPT is. GPT-3 went out last year from OpenAI. It's been an astonishing model because it's basically it has the knowledge of all the web, so it knows everything. And GPT-2 is the parental of that particular model. It's a pretty interesting model. It's a decoder model. And so he generated this text. In this course, we'll teach you how to make an HTML file using HTML5. This course will let you also do a bunch of things to get the most out of HTML5. So you never have to write an entire document. Okay, so somehow he, by itself, he started generating some random stuff about some technical stuff, HTML. So it's interesting. And obviously you can play with the hyperparameters of this pipeline object. We're not going to do that, so try by yourself. But for instance, we can add a model in case we don't want the GPT-2, but we can use the distill GPT-2, which is a lighter version of GPT-2. And so this goes into the pipeline, sorry, not here. But here we can pass, as I said, the hyperparameters. So for instance, the max length, I want the text generated to be at most 35, for instance. And then we can tell also the generator to return not just one piece of text, but a number of sequences greater than one. For instance, let me say 2 in this case. Let's try to run it. So it's downloading this Distill GPT-2. So you see that the size is much smaller than before. And as you see here, we have got 2 sequences. Let's try to see what we are about. In this course, we will teach you how to manage and understand what happens when you are running your own application. Makes sense. In this course, we will teach you how to build from scratch. In it, you will learn how to assemble your deck of cards from various popular playwrights like Richard BR. Honestly, here it got crazy, right? So he's generating some text, but obviously is not precise, it's not consistent from a semantic point of view. So, you know, you can actually try with the hyperparameter, try to play around with the parameters and see whether your results are improving or not. Let me go back to the lab again. Here is fitting the model, so something is happening. So let's continue a little bit again with the transformers. So if you remember, I said at the beginning of this webinar that we needed a couple of snippets from the previous lecture. And in particular, what I need is actually using this paragraph, number 1, that speaks about EC2 spot instances. So I'm just gonna copy it and pass inside the our Jupyter notebook. And in particular, what I want to perform with you now is simply try to perform question answering from that particular snippet of text using the pipeline object. So I'm going to call this QA, standing for question answering, which is a pipeline object, and I use the question answering pipeline. And then I can say, well, I can call the QA by passing what? We need to pass the question we are interested in, and we pass this as a dictionary. And let me say like this, and then we have a context, which is actually the part of the text from which we are getting knowledge in order the machine to be able to answer to that question. Think about passing a full Wikipedia page. You want to be able, your algorithm to be able to answer to some question, basically reading from Wikipedia. So here we are going to basically use the paragraph 01 as the context, and the question can be which service does manage spot training use for training. Obviously I know that this text is speaking about managed spot training, okay? So I expect that the algorithm is going to be able to extract the exact sentence from that paragraph. Yes, here we go. Look at this. So he is providing the start and the end key in this dictionary, which stands for the fact that the answer is taken from the 28th character to the 53. So basically here you go through the characters. This is the 28th, and Amazon EC2 spot instances is the answer for which service does manage spot training used for training. Manage spot training is performed by Amazon EC2 spot instances. So he is understanding actually from the text that we have provided that Amazon EC2 spot instances is the answer for that particular question with a score, probability score of 0.83, which is a very high score, which means that the algorithm is pretty sure that that is the correct answer, okay? And that's amazing because actually with just a couple of lines of codes, you are able to build a question answering application using the transformer technology. And a natural question is, where can I use this knowledge? Well, think about a chatbot. You can build your own chatbot by passing a specific context knowledge so that your chatbot will be able to answer to people in a very accurate way. So a possible application is a chatbot. So try by yourself to build your chatbot because you have the technology and it's pretty direct to using the transformer library. Here we finished the training. Looks good. So let's see whether we have some metrics at the end. So I go through here. We don't yeah, here we go. So we have some metrics. But it's not I want to see the metrics on the test set. I'm not able to see them. Well, here I have some test score. Here we go. We have the mean square error calculated as 164.38. It's okay, but to me, and this is my suggestion, when you want to understand whether you are doing well with the regression stuff, it's always good also to print the R-square, which is a measure somehow that it normalizes the mean square error. And well, we have to understand from the previous epochs whether these went down in order to see whether we are doing well. So let me check. Here, for instance, you have 165, then 164. So it's getting down somehow. It should be good if we are able to see each single step, but you know, it's not the time now to check each single line because we are shortage of time. But once we got that, we can actually perform some prediction by calling the deploy function from the Sagemaker model that we built. So it's taking some time here. Just wait a few seconds. Okay, so let me go back again to our NLP stuff. And what I want to perform now is the summarization task. So I'm going to copy the paragraph 2 in available here in our GitHub repo. And without a surprise, you can actually perform a summarizer, which is a summarization pipeline, obviously. And you can call this object by passing basically the paragraph that we have here, paragraph 02. And so the summarization pipeline is going to ingest that text, which can be also much longer than that stuff, and is going to summarize it. And my suggestion is try to look at the documentation, because here you have some parameters that you can control on, like, for instance, the length of the summary you wish to have, or even the hyperparameters used in the decoding phase of the transformer model that is actually necessary to produce the summary itself. So check it out by yourself. Just to see, the objective here is just to show you that given a long text like this one, we are able to get a summary that possibly makes sense. I don't know, let me check. America has changed dramatically during the recent years, not only as the number of graduates in traditional engineering discipline declined, but in most premier American university curricula now concentrate on encourage largely the study of engineering science. Okay. America has changed dramatically during recent years. The number of engineering graduates in the US has declined in traditional engineering disciplines, such as mechanical, civil, and aeronautical engineering. It makes a lot of sense to me, guys. And the nice fact is that this model is actually performing some text generation, if you think about, because it's not gonna extract some sentences and wrap all together in just a summary. But think about here, the number of engineering graduates in the US has declined. Here it says that not only has the number of graduates in traditional engineering discipline declined, okay? So it's actually generating some text. It's not just copying from the original sentence. So I really like the summarization pipeline, because it's actually a very nice, friendly function that allows you to generate some summary in a pretty straight way. And if your results are not as good as you can expect, my suggestion is try to play with the hyperparameters inside this function. Okay, it should have completed that stuff. Not yet. So here, basically, what is performing is taking the model that we trained, deploying the model so that we can perform real-time prediction using that particular model. So he says that it takes 5 minutes, so possibly we are getting to the point. And therefore, in order to wait, let's wait a couple of minutes again. And I want to conclude basically the part of NLP using a classical pipeline used for translation. Think about Google Translate. Well, beyond that, there is a machine learning model. So let's try to see and understand how those technology works using a translator pipeline, even calling the Hugging Face, obviously. And I'm gonna call the pipeline translation. And then I can pass the translator. I can pass a sentence. For instance, I'm gonna use the French, Secours produit par Hugging Face. So if you haven't got what I just said, let's try to run it and see whether it's gonna work or not. So let me also specify the model. The Helsinki should be the Helsinki NLP, and then we use the Opus ML French English. This is not correct. Helsinki NLP, let me check. Possibly I made a mistake. Here we go. Opus MT French English. This is the model I want to use. So it's MT, non-ML. So here is getting the model, It's not as way, it's 300 megabytes, it's fine. And let's see what does this sentence mean. We got some results. Translation text, this code is produced by Hugging Face. So if you didn't get that, you have here the translation, and I can tell you that the translation is perfect. Let's try with another sentence. Let me say, j'attends le bus à la station. This is pretty direct, I believe. And think about, I wasn't so clear with the accent, but he's able to understand that I'm speaking about to the station, alla station. So I'm waiting for the bus at the station, which is perfect. So the translator works perfect. So again, another way to perform NLP with transformers. And let's go back to our lab. So we got we deployed the model using the deploy. And now we can perform actually some prediction. Here we got some prediction using the first test set, the first example in the test set. We predicted -12. The actual delay was -20 with an error of 7.72. It's okay, but you can try by yourself and see whether with other example works. So at the end of the day, we have understood how to use Python to prepare the data. We use Sagemaker to train a linear model, and we deploy that linear model after training in Sagemaker. And remember, we actually use this pre-trained model from a container image called linear learner. And the nice thing about Sagemaker is that you can start with some pre-trained image like this one, and then we feed the model, and then we deploy that model, and we perform some prediction. That's pretty much the end of the day. So let me check whether there are a few questions. Well, it seems not. So thank you for your attention.
All right. Thanks, Andrea. That's it for today. And thank you for everybody that joined us throughout this whole series. Let me just say that, Andrea, it's been a true pleasure working with you on these webinars. Hopefully we'll get to do more in the future. And it's been a pleasure having you all as an audience. You've been great. We received so many good questions and inputs through these 5 episodes. So the final reminders of this series, you will receive the recording as soon as it is available. If you could spare a minute to fill out our end of webinar survey, would be extremely grateful. Every input suggestion would be most useful. We'd like to know more about what you'd like to see in the future, where we can improve, what did you like, what you didn't like. Any feedback is appreciated. And of course, as mentioned before, you can still watch all the previous webinars on demand on cloudacademy.com/webinars. And that's it. Thank you again to everybody and to Andrea for leading this wonderful series. And until next time, goodbye, everybody.
Bye-bye.